Hey guys, welcome back. In the last video, I worked on radicals, and I also did some functions, transformations in previous videos, so you're welcome to check those videos out. Today, what I'm going to do is I'm going to explore some trigonometry. Trigonometry has historically been, for many grade 11 students, one of the worst sections known to man. So, when it comes to their grades. So I figured I would take some time, do a whole video on trigonometry. I do not know how long this video will take, but we'll go with it. So we have part 4, trigonometry. I'm just going to call it trig. Okay, number 1. Draw each of the following angles in standard position. Okay, so what that means is you're going to draw the 4 quadrants. We have quadrant 1, 2, 3, okay, and 4. All right. Now, in quadrant 1, we've got, let's see, 50 degrees. What that means is you're going to be drawing a line coming from the origin. This is the origin. And that line is going to be called the principal arm. And so you have to draw it such that you make 50 degrees with the horizontal, right? So you've got 50 degrees, and 50 degrees is less than 90. Right? So, and it's just above halfway. Halfway is 45 degrees. So all you have to do is draw a terminal arm such that that line that you've drawn makes a about 50-degree angle with the horizontal line. Okay, and it would be in quadrant 1. Now, what about the second question, right? This is part A. What about the second question? Second question is 140. Let's see, that's above 90. 90 is right here, right? So this guy is 90. So we have to go above 90, so we're in quadrant 2 probably, because this line would make 180, so it's less than that. So what you're going to do is you're going to draw a line such that you've got maybe 40-degree gap, and that would give us the 140 degrees, and that is part B. Now, what about the next one? So notice these are positive angles. Positive means going counterclockwise from the horizontal. What if you have negative angles? What do we do? Well, what we do is we go clockwise from the horizontal. So we go this way. So I've got some of you messaging me on Instagram. Fantastic. So 148 degrees. That is, again, in the negative side, that's bigger than negative 180, more positive. So it's going to be somewhere in quadrant 3. Right? So how much do we need? About 32 this way, right? This is about 32 degrees. So this guy going this way is about negative 148 degrees. Okay? And 830, you do the same thing. You just got to go counterclockwise because it's positive, right? And how much is a full rotation? That's 360, right? And if you do it one more time, that's 360 by 2, and that's 720. So if you go 2 full rotations, you end up back at the horizontal, and you're at 720. Now, how much more do I have to add on to 720 to get 830? The answer is 110 degrees. So you're essentially, what 830 means is just drawing a 110-degree terminal arm, and that is going to be just past the 90, such that you're in quadrant 2 still, and that is your terminal arm. Right, so that's 830 degrees. Negative 470 means going negative a full 360 plus a little bit more, plus 110. So that's going to be the opposite to that arm. So it's going to go this way, right? So you're going to do a full negative 110, but negative 110 is essentially the same as negative 470 degrees. And that follows with this trig identity, right? So you got, are you guys familiar with the fact that 2 pi is 360 degrees? And that pi is 180 degrees. That's a conversion from radians to degrees and back. So if you're doing, you know, a 45-degree angle, right? Or actually, let's do it this way. Let's see, 360 degrees plus 45 is 405. So 405 degrees will look the same as 45 degrees, right? So it'll just be an arm going this way in the quadrants. So you're going to have sine, essentially, that's sine of, an angle theta, okay, or cosine, is equal to sine of that same angle theta plus 2 pi or 360 degrees, right? So this is a trig identity. So that's basically part one. And let's see, for each angle in question 1, state the principal and related acute angle. So the principal angle is very simple. That's just the angle that it makes with the horizontal, right? So the line that you've drawn, the angle that it makes with the horizontal. The first one's obvious, right? It's 50 degrees because it makes that angle with the horizontal. And it's going counterclockwise, I believe. 140 degrees, that's simple, it's 140. What about negative 148? Well, negative 148, all you have to do is go, well, we noticed that there's 32 degrees here, right? So this is 180 plus 32. That should be, what, 212? And what about 830 degrees? 830 degrees was the same as 110 degrees, right? We covered that. So that is 110. And negative 470 is negative 110. So negative 110 would leave a gap of about 80 degrees here. So it would be 180 plus 80. That is what, 260? Right? So that's that. That's the number. That's question 2. For each angle in question 1, state a positive and negative coterminal angle. So another angle for each question such that, okay, so you have, let's say you have, let's do a new page. So, you got 50 degrees, right? I suppose the negative coterminal angle is the angle going counterclockwise such that you've got the same line, right? So how far do you have to go? Let's see. Well, this is 40, right? Okay, this is a full 270. So to go another 40 means to go negative 270, right? Because I'm going clockwise, minus 40 degrees, right? So you get negative 310 degrees. That would be the coterminal for that question. So that's number 3 in gist. If you start out at a negative, what is the positive, angle that you would go to get the same arm? Okay, so that's that. Whoa, I think I went really far ahead in terms of the page number. So determine the remaining 5 trig ratios for each of the following. So I'm on number 4. Just because I don't want to make this too long a video, and then you guys are going to sleep through it. So we got sine theta equals 2 over 5. There's a beautiful trig identity that we can use here. We got cosine squared theta plus sine squared theta, right, equals 1. Okay, that means if I square this ratio, okay, and I add it to the square of the cosine ratio, which is some number over some number, I get, and I add it together, I get 1, right? So that's one way to do it. And let's see. Another way to do it is to draw a triangle, right? So I can go, if this is angle theta, sine is, if I remember my SOHCAHTOA, right, is opposite over hypotenuse. So that means that if this is the hypotenuse, it's 5, right? And opposite to that is 2. And I can use Pythagorean theorem to figure out what this is. And the reason why I need that is because then I can figure out cosine and tan in one shot. Why don't I do that instead? So, so I can use Pythagorean theorem. So let's go. So 5 squared equals x squared plus 2 squared. 2 squared is 4. Right? So x squared, whoops. So x squared is going to be 25 minus 4. Okay? And so x is going to be the positive square root of 21. And the reason why I say positive is because I've stated that x is a length, right? So I've got that now, and so I can do cosine, right? So cosine is going to be adjacent over hypotenuse, right? adjacent over hypotenuse. So cosine theta is going to be x, which I found to be root 21, divided by 5. So that's cosine. What's tan then? Tan is going to be opposite over adjacent, right? That's TOA, SOHCA TOA. Okay, so opposite over adjacent. So just do it. So 2 over root 21. And I forget what this is called. I think it's called rationalization, where you make the square root on the bottom go away. And that's just multiplying the top and the bottom by root 21. That's essentially what it is. You can multiply by something that's 1. It doesn't change the number, right? So it's going to be 2 root 21 divided by 21. And that's it, basically. That's how you do it. We could do the same trick to get the next question, right? Tan theta equals 8 over 7. So all you have to do is draw a triangle, and it is opposite over adjacent, right? So right triangle, remember that, so it has a right angle, and that's it. And now use Pythagorean theorem again, right? So this is h. So I put h for hypotenuse, right? So h squared equals 7 squared plus 8 squared, right? And so you get 49 plus 64. So once you figure out what that is, let's see, 9 plus 4 is 13, 6 plus 4 is 10. So that's going to be 113. Okay, so h is going to be square root of that. Okay. So you've got you got h equals root of 113. Right. And you can find cosine. So cosine, okay, is going to be cosine theta is going to be adjacent over hypotenuse. So it's going to be 7 over root 113. Sine theta is going to be 8 over root 113. There's something that I need to mention as well, I think, and that's that to get a tan ratio that's positive, right, you can draw 2 arms, right? And that would give me a tan ratio that's positive. One in the first quadrant and one in the third quadrant. This is the cast rule, by the way. I think cosine is positive. Is that right? That doesn't look right. Cast, I think, goes this way, right? Cosine is positive alone, so that means sine is negative, and tan is negative. All are positive. Sine is positive, and tan is positive. So if all are positive, tan is positive, and here tan is positive as well. So what that leaves me is cosine and sine being also a negative, right? So actually the correct way to put this is either plus or minus 7 over root 113 and plus or minus 8, because you have one option here where the trig ratio is positive and another option here where the trig ratios are negative. So keep that in mind. There are 2 answers, and that's the reason why. It's because of the cast rule. So there's that, and that's part B. And the same applies for part A. So why don't we quickly go back to that just so I don't get you guys all screwed up. So the cast rule. So let's do that. So sine is positive, right? So if sine is positive, I'm either at all are positive or S, right? So the second quadrant. So it can either, so cosine, it looks like cosine can be positive or negative, right? Because here, cosine will be negative because only sine is positive. So tan is also negative. This is probably confusing the crap out of you guys, but hopefully it'll make sense with practice. So this is positive and negative, and so is tan. So keep that in mind. Sine is the only one that's straight up positive. Now let's make things even more complicated. We've got secondary trig ratio, secant theta. And if you check out my last video, I explained that to convert between primary and secondary, if you start with an S, that means you reciprocate to a C. And so if you have secant theta, right, that means it's 1 over cosine theta, right? You see that? You start with an S, you end with a C, okay? So that means that if I start off with 6 over 5, okay, that's 1 over cosine theta. If I flip it, then cosine theta, if I flip both sides, right? So I flip 6 over 5 to 5 over 6, and 1 over cosine theta to cosine theta over 1. Then I get cosine theta over 1, which is cosine theta equals 5 over 6. Okay, so I've got cosine theta for sure is positive. So quickly, where am I? Right, I'm in the first quadrant, and I'm in the fourth quadrant. Okay, so I'm in the first and the fourth quadrant. So keep that in mind. So what kind of angles are we talking about here? Well, we got to draw our triangle, and we got theta, okay? And theta, cosine is adjacent over hypotenuse, and that's 5 over 6, okay? So we got to figure out what this is, the opposite side. So we got to figure that out. So we just use Pythagorean theorem. So 6 squared equals 5 squared plus x squared. Okay, 6 squared is 36, so write that down, and 5 squared is 25, okay? So x squared is going to be 36 minus 25, which is 11, okay? So x is going to be plus or minus square root of 11, but I'm just going to leave it at root 11 for now, and we're going to decide what ratio gets the minus, but it's pretty obvious it's going to be the other two, right? Gets plus and minus. Because here we have all are positive, and here we have just cosine is positive, which means sine and tan are negative, and here sine and tan are positive. So that means sine theta, right, is going to be equal to plus or minus opposite, which is root 11, okay, over hypotenuse. And so that's another one. And tan theta, just write it here, tan theta is going to be opposite over adjacent, so plus or minus root of 11 over 5. And that's it. So we get tan, cosine, sine. And I'm assuming all they want here are... Oh, no. Actually, we have to get the secondary trig ratios as well. Whoopsie. Luckily, it's not that bad to get the remaining trig ratios. All you have to do is flip, right? So if you want cosecant, right, then you'd flip the sine ratio, and it would be plus or minus, 6 over root 11. And so that would turn into, if you rationalize, that would turn into 6 root 11 over 11, right? So that's an example. Cotangent is when you flip tan, and so it's going to be 5 plus or minus 5 root 11 over 11. So all practice. Next, state the principal and related acute angle for the point. Okay, so what point are we talking about here? So we have to think about this as a coordinate system. And we talked about this earlier, where this is the origin. That's the point 0, 0, so Greek 9 stuff. And what this means is that x is going to be 4, and y is going to be negative 5, right? So if x is 4, we're here so far. Y equals negative 5, we're somewhere down here, right? So we need to figure out the principal angle. Principal angle is all the way from the horizontal axis, right? And we need to figure out what that is. Well, the best way to do it is to first find this angle, right? Because we know that this is 4. We know that this is 4, and this is negative 5. So we can figure out what that theta is, right? So we go, you go, what is this? Opposite over adjacent, so tan theta, right, equals, and just use positive numbers for now, just because we want to know what that chunk is. So tan theta equals 5 over 4, and so use your calculator, right? And you get your answer. Let's see. Let me try to use my calculator. Got caps on. So let's switch to scientific. Okay. So 5 divided by 4 is 1.25. So all you do is you go, let's see if this works, inverse tan, and you get 51 degrees. I hope that's correct. 51 degrees. Check your answers. So we've got 51 degrees, and so this little thing, right, is 51 degrees. That means the related acute angle is 51 degrees, and the principal angle is going to be 360 degrees minus 51, right? And you end up getting 309. Okay, so that's the first question, and then you could do the same to get your last two. So I'm going to skip that. Solve for theta in the domain 0 to 360, so the full 4 quadrants. For sine theta equals blah. Let's do the last one. I'm assuming that the last one is the hardest. So you get tan theta. Let's see, 6d. Tan theta equals 4.774. And so solve for theta. So this is pretty easy as well. Theta equals inverse tan, right, of 4.774. Okay, I'm going to try to use this calculator and see what happens. Clear this. Clear everything. 4.774. And do inverse tan, and I get 78.2-ish degrees. Okay, so I get that. And how do I, so how do I get, are there more angles, right? Is this the only angle? Well, yes, according to the CAS system, that is one possible angle, with this being 78.2 degrees. Although that's kind of off, that looks more like 50, but anyway, it should be really, really up there. But anyway, there's that, there's 78.2 degrees, and there's also tangent being positive here, right? So that means that this could be 78.2, which means that the other angle is 180 plus 78.2. So what is that? What is that? 258.2, I believe. Makes sense. Okay, so there's that. And next, using special triangles, find the exact value. Now this is pretty simple, right? You've got two special triangles, 45, 45, 90, and opposite the 45s, you got 1 and 1, and then using Pythagorean theorem, you can deduce that it's a root 2. The other special triangle is 30, 60, 90. Okay. Notice all these angles add up to 180. That's the principal rule of triangles. All angles add up to 180. Opposite the 30, you have 1. So the hypotenuse is double that. And then by deduction, you can find through Pythagorean theorem that the final side length is root 3. So find the exact value. So what does that mean? Well, it wants secant 60. I'm just going to do D. So secant 60. Secant is 1 over cosine, right? So 1 over cosine is what they want me to find. 1 over cosine 60. Let's find cosine 60 first, right? Well, what triangle am I using if I have 60 degrees? I'm using this one, right? I'm not using this one because there's no 45. So cosine 60, well, what's adjacent? Because cosine is adjacent over hypotenuse, right? So I'm doing adjacent divided by hypotenuse. This is adjacent, and this is the hypotenuse. So cosine 60 is going to be 1 divided by 2. So 1 over cosine 60 is the reciprocal, so you flip them. So secant 60 should just be 2 over 1. 2 over 1 is just 2, right? So that's it. That's the exact value. Next, in triangle ABC, the angle A is 25 degrees, B is 6 meters, and C is 13 meters. Find angle B, angle C, and side length C. Let's do that. So, so we got number 8. I'm just going to draw a random triangle, A, B, C. Okay. This guy, angle A, is 25 degrees. Side length B is 6. Side length C is 13. Find angle B, C, and little c. So we've got, notice we've got two side lengths surrounding an angle. This case, you can use something called cosine law. If we had 13, over here, then what we can do is we can use sine law. But since we have 13 over here, we resort to cosine law. So all you have to do is, I don't know why it says find C, little c, if C is given, right? Notice that. So C is already given. So you don't have to actually find it. So all we have to do is technically find angle B and angle C. Okay, well, angle C, so angle C is no problem. We have to first resort to finding A first, then we can use sine law. So let's do it. Okay, so A over sine 25, okay. Actually, what am I doing? That's sine law. Cosine law. So cosine law goes as this. A squared, right, the side length opposite the angle, squared, equals the other two lengths, squared and added, minus 2 times each side length, and then multiplied by cosine the angle, right? So I'm not going to do this part, but punch this through your calculator, then you'll get what A is, okay? Once you figure out what A is, the rest should be straightforward, because then you're going to find angle C, for example. Sine of angle C divided by 13 is going to be equal to sine of 25 over whatever value you got for A. Okay, and then you can multiply both sides by 13, and what that means is you could put 13 over here on top and evaluate this using a calculator, okay, and then take inverse sine and you can get angle C. Now once you have angle C, notice I've got a triangle, right? So angle C plus 25 plus B is going to be equal to 180. And so you can find angle B for your final answer. And so it's going to be 180 minus whatever you get for angle C minus 25 degrees, and you're basically done the problem. And that's that. And then last question, this is beautiful. We've got a ship at sea, HMSS Fontana. Okay, I'm going to call it F. And then it spots the HMSS Bottner and the SS Martin. So we've got the Bottner and the Martin. Okay. I'm obviously using letters to suggest each boat's name. And so the Fontana measures the distance between, measures the angle between the Bottner and the Martin to be 27 degrees. And so that means that this angle right here is 27 degrees. Okay? The distance between the Fontana and the Bottner is 199 meters. So this thing, F and B, this side length is 199 in meters. The Bottner measures an angle 52 degrees between the Fontana and the Martin. So between the Fontana and the Martin, so that means that this angle is actually 52 degrees. And so what is the distance between the Fontana and the Martin to the nearest meter? Okay, so I need the distance between the Bottner and the Martin, so this distance. So here I clearly have to use sine law, right? You can't use, SOHCAHTOA because there is no right angle, and you'll see that in a moment because all angles add up to 180, and so I can find angle M, right? So 180 minus 52 minus 27 is going to be angle M. And so 52 plus 27, that's 99, or excuse me, 89, and I'm off, 79, and so you get 101 degrees. So we have that angle. This is 101 degrees. Obviously, it's not drawn to scale. That should be a lot wider. It should be more obtuse, rather than acute. And so now we can do our sine law, right? So sine of 101. Actually, let's do side lengths on top. So in sine law, you can either do side lengths on top or sine of an angle on top. So I'm just do side lengths on top. So 199 divided by sine of 101 equals, so this guy over this guy equals this guy over sine of that, right? So d over sine 27. Okay, so now to solve for d, to isolate for d, all you have to do is multiply both sides, right, by sine of 27. Typically what you hear is you could do cross multiplication. There's really no point in that. There's a waste of you're doing too much math at that point. Just multiply both sides by sine of 27 and you're pretty much good. Now punch that into your calculator and you've got the distance between the Bottner and the Martin. Follow us on Instagram, Lehigh Tutoring. Subscribe to us for more for more of this free math help, and visit our website lehightutoring.com. We've also got a Twitter. Twitter is at Lehigh_tutoring. I'm going to leave all the links in the description. Thanks for following us. Name's Martin. Peace out.